Okay, let's talk about the invisible magic happening right under our noses every single day. If you've ever sat down, opened your laptop, and wondered how your work data actually stays safe when you're miles away from the office router, well, you are definitely in the right place. Today, we're taking a deep dive into what we call the secure commute. We're going to completely demystify the complex cryptographic steps that make remote access possible by unpacking the real magic of SSL VPNs.
Think about it for a second. What is literally happening when you connect to your office intranet from a crowded, completely unsecured coffee shop? To really get a grip on this, we're going to frame today's explainer around a personal commute, but for a single data packet. We'll trace its exact journey, from your laptop, straight through the wild west of the open web, and safely into your corporate server.
All right, let's dive into our roadmap for this explainer. First up, the coffee shop dilemma. 2, SSL VPN basics. 3, the TLS handshake process. 4, authentication and tunneling. 5, the packet's journey. And we'll wrap up with number 6, the true essence of VPN.
Starting with Section 1, the coffee shop dilemma. Public Wi-Fi versus the internet. Before we can appreciate the brilliant solution, we have to establish the stakes. Picture your company's internal network. It's sitting pretty on a safe, private IP range like 192.168.10.0/24, housing all the critical stuff, the ERP, the file servers. Now, picture yourself. You're chilling in a coffee shop, connecting to public Wi-Fi that you're sharing with a dozen strangers. And who knows, maybe someone who's a little too good at packet sniffing. The only thing standing between you and your safe office is the vast, untrusted internet. That right there is the threat.
Moving right along to Section 2, unpacking SSL VPN basics and bridging the gap.
So how on earth do you safely cross that minefield? Well, your company provides a single, armored entrance, an SSL VPN gateway. Now, despite what the old-school acronym implies, an SSL VPN isn't just one monolithic protocol. It's actually a remote access mechanism built directly on top of TLS, Transport Layer Security. Its core mission is beautiful in its simplicity. It lets you securely connect back to the internal network over standard HTTPS. And it usually does this in 2 modes. You've got clientless or web portal mode, where you just use a normal browser for quick access to specific files. And then there's client mode. This requires a dedicated VPN app, but it sets up a full tunnel, giving you comprehensive, unrestricted access to the entire intranet.
Section 3, the TLS handshake process. The secret handshake.
Now, what's really interesting about this process is how we forge that tunnel at the microscopic level. You have to establish absolute, undeniable trust before a single byte of actual work data is allowed to move. To build this encrypted channel, TLS executes 3 crucial steps. Step 1 is authentication, verifying that the gateway is who it says it is. Step 2 is key exchange, utilizing some seriously brilliant math like Diffie-Hellman or ECDHE to agree on a shared secret. And step 3 is building the actual encryption channel, using heavy-duty algorithms like AES or Cha-Cha-20, locking down all the traffic that follows.
Let's look a little closer at step 1. This whole thing kicks off over standard TCP port 443. Your browser connects, and the gateway hands over its digital certificate. At this point, your browser essentially acts as a ruthless bouncer. It rigorously verifies this certificate against trusted certificate authorities. It's checking if the signature is valid, making sure the domain is a perfect match, and confirming the cert hasn't expired. Only if every single check passes does your client agree it's not talking to an imposter, completely shutting down middleman attacks.
Once that trust is rock solid, we need a way to actually encrypt the data. Enter the magic of the TLS key exchange, usually handled via ECDHE. Instead of just sending a raw password over the internet where literally anyone could copy it, the gateway and your client each generate their own key pairs and exchange only their public keys. Then, using some mind-bending mathematics, both sides independently compute the exact same shared secret. Because the secret is never actually transmitted across the network, there's simply nothing for a hacker to intercept. Both sides then use it to generate the final session key.
On to Section 4, authentication and tunneling, building the armored transcorn.
With our machine-level trust locked in, it's finally time for human-level authentication. And this is absolutely crucial. You only actually log in after this heavily encrypted TLS channel is up and running. Your credentials are fully protected from the very first keystroke. You might authenticate using a standard username and password, multi-factor authentication like a one-time password or an app push, or even certificate-based login,
Once the gateway says, yep, that's you, your official VPN session is established. You're in. Okay, the tunnel is opened, but what actually gets shoved inside it? Well, that depends entirely on your routing configuration. In a full tunnel setup, absolutely everything, all your web surfing, all your internal traffic, gets forced through the VPN back to the office. But in a split tunnel setup, only traffic specifically looking for the company intranet, like that 192.168.10.0 range we mentioned, goes through the secure tunnel. Everything else bypasses the corporate network and heads straight out to the public internet. It's a really smart way to save the company's bandwidth. And this brilliantly illustrates what's happening on your machine. Behind the scenes, your computer handles this new tunnel by creating a virtual network interface right in your operating system. It slaps a virtual internal IP address onto your laptop, say 10.10.10.10. This effectively tricks your laptop into believing it is sitting physically inside the office building, plugged straight into the switch.
Section 5. The packet's journey. From cafe to internal server.
The stage is set. The tunnel is built. Let's actually track a single data packet's chronological commute right now. Start the clock. At 0 milliseconds, your app, maybe an internal web portal, fires off a request. Just 1 millisecond later, your OS routing table intercepts it, sees it's meant for the corporate network, and shunts it over to that virtual VPN interface. At 2 milliseconds, the VPN client encrypts the packet using our mathematically perfect TLS session key. And at 3 milliseconds, this armored package is encapsulated into a standard HTTPS payload and launched into the chaotic public internet.
It zips across the internet and hits the company's gateway. Let's pick it back up at 10 milliseconds. The gateway catches the HTTPS payload and instantly performs TLS decryption using its matching session key. At 11 milliseconds, we get session mapping. The gateway inspects the decrypted packet and confirms exactly which authenticated user it belongs to. Finally, at 12 milliseconds, knowing the packet is totally safe and authorized, the gateway routes it directly to the internal server at 192.168.10.20. The server does its thing and sends the response back through the exact same reverse process.
Bringing us to our final section, number 6, the true essence of VPN, beyond the acronyms. That microscopic journey is quite the commute, right? Taking a step back for the big picture, we should quickly differentiate SSL from traditional IPsec VPNs. IPsec operates way down at the network layer, layer 3. It needs complex routing, and it's mostly used for site-to-site connections, like hooking up a branch office to headquarters permanently. SSL VPN, though, operates higher up at the application layer over HTTPS. It is specifically tailor-made for exactly what we just broke down, remote access. It's incredibly flexible, works flawlessly from literally any coffee shop Wi-Fi, and requires almost zero setup for the user. So the crucial point is this. Distilling it all down to its absolute core, an SSL VPN means using TLS over the untrusted internet to establish a secure, remote access tunnel into an intranet. It's not just about a raw network connection. It's about engineering an intelligent, encrypted pathway that completely shields your work from the outside world, giving you the seamless experience of sitting right at your desk. It really is a brilliantly elegant solution to the incredibly messy reality of the public internet. So the next time you pop open your laptop at a cafe, take just a second to appreciate the cryptographic bouncers and intense mathematical handshakes working in the background to protect your data. Which leaves me with one final thought for you. How secure is your own remote commute? Do you really know exactly how your data is traveling today? Thank you so much for joining me for this explainer. Keep learning, stay secure, and I'll catch you on the next one.